Eric Burgess here, and we've been given the following statement. P is within 0.0001 unit of 10. And they want us to express this statement in math. So whenever they say within, they're talking about a distance. And so distances we represent by a minus operation. So if we want to know like the distance from 7 to 5, we would do 7 minus 5. That gives us 2. So in this case, they want a range, and I think it's helpful to draw a picture. If we draw a picture and we have the number 10, we want to be within 0.0001 of this 10. So that means that we want to be 0.0001. There's going to be some number that corresponds with this. And going this way, 0.0001, there's going to be some other number that corresponds with this. And in between all these numbers are all the values of P that we'll accept. P just has to be between these two numbers. It has to be within them. So we're not including the edge numbers. We are strictly within them. So from here we say, okay, well, we are at 10. We're at 10. And we're going to move some amount P, right? We're at 10. We're going to go a little bit over P. And then we're going to go a little bit over more P. And the rule is we can never pass 0.0001 past. So this number right here is our hard edge. So we say, okay, well, we can move P this much. P can be so if this is 0.0001, well, we can move anything less than this. So we can move 0.00001. We can move less than the amount that we have here. We just can't move more than this amount because then we would have moved past that number, and that's where our limit is. So that's kind of like the thought process. So 0.0001 is what we would call a tolerance. It's an amount. We want to be within that amount of accuracy. So we say we want to be within, so 0.0001, and we want to be within this region, within this amount. And so this is like a tolerance here. We don't want to be greater than this amount. And what we're saying is that 10 minus P, the distance between 10 and P should always be less than this total distance. This is like the most distance you can have. And we're going to have an absolute value here, right? Because we can be above this distance or we could be below this distance. And since we could be above or below the distance, we're going to have an absolute value. So that if P is negative, well, let's just say P is negative. Let's say that P is negative 0.00001. It's going to become positive, and that'll be 10 plus this number, which will still be within our area here that we're allowed to be. And the same thing's true if P is positive, then we're going to be somewhere in here because it's going to stay negative, and we'll still be less than this amount. So this is how you would write what we call a tolerance. This is actually an incredibly important idea to wrap your head around now, because later when you get into calculus, they're going to start writing statements like this for what's called the formal definition. It's a proof of what's called a limit. And you may or may not see it depending on your teacher. But if you do, this form will show up again. And if you don't have a grip on it, it's going to be, because you're not going to want to have to worry about what this form is. You're going to want to think about the bigger concept. So take a moment here to really understand what this is saying in terms of a threshold, an accuracy, a tolerance. And if you can do that and really, really get your head around it, maybe do a couple other problems that are similar to this, it will be well worth the payoff later in your education. I can promise you that. If you have any questions about this, let me know. By the way, this would be our answer, this expression. If you're a Citrus College student, definitely feel free to swing by online tutoring. We are there to help you out. Subscribe, and we'll catch you in the next problem.